Welcome to MRL. In this learning session, we'll be learning about the properties of sets, and this is the third part of learning of sets. In this, we'll be learning the properties. The various properties are the union of set is commutative. So let us understand this. Union of sets is commutative. That means if you take A union B, if you take A union B or B union A, that means both are equal. That means A union B is equal to B union A. That means union of set is independent of order of union. You take the union of A and B or B and A. So therefore, union of sets is commutative. Intersection of sets is commutative again. A intersection B is equal to B intersection A. Whether I take A intersection B or B intersection A, the set remains the set which we obtain by operation remains the same. Union of sets is associative. That means we can group A union B and then find the union of A and B and then find the union of C, or if we can find the union of B and C and then find the A union of B union C, that means the resulting set is the same. That is the union of sets is associative. Intersection of sets is associative. Again, if you take A intersection B first and then take intersection of C, or A intersection first take B intersection C and take A intersection B intersection C, the resulting set is again the same. That means intersection of sets is associative. Remember that. Union of sets is distributive over intersection of sets. It means that A union B intersection C, when we take A union of B intersection C, it is the same as taking A union B first and then taking intersection of A union C. LHS is equal to RHS. Intersection of sets is distributive over union of sets. This is very important again. A intersection B union C is the same as taking A intersection B first and taking union of A intersection C. LHS is equal to RHS. The resulting sets are the same. Therefore, remember these 6 very important properties. Again, another very important property is De Morgan's laws. These laws give the relation between the complement of sets. Now let us define the two De Morgan's laws, that is De Morgan's first law, De Morgan's second law. The De Morgan's first law states that the complement of A union B, the complement of A union B is equal to the intersection of the complements of the two sets A and B. The complement of union of two sets is equal to the intersection of the complements of the two sets. In the De Morgan second law states that the complement of A intersection B is equal to union of the complements of the two sets. That is, the complement of intersection of two sets is equal to the union of the complements of the two sets. A very important law, remember that. Now, cardinality of set. The number of elements of a set is denoted by Na, and this number is called as cardinality of set. If you have a set A is equal to with elements 1, 2, 3, the number of elements is 3, therefore Na is equal to 3. So the cardinal number of set A is 3. Remember that. Now the cardinal properties. Let us understand the cardinal properties. If the number of elements of A union B, the number of elements of A union B is equal to the elements of A plus elements of B minus elements of A intersection B. A very important relation. Now, the elements of A plus elements of B is equal to elements of A union B plus elements of A intersection B. Now, for disjoint sets, you should remember that the elements of A intersection B is 0, and therefore Na plus Nb is equal to Na union B, a very important cardinal property. Remember, elements of A plus elements of B is equal to elements of A union B. All the operations and properties on sets can be proved by taking examples and also can be proved by drawing Venn diagrams. We'll be learning about this when we take examples on sets as a separate study. Okay, remember that. Now here I have purposely taken Venn diagrams of De Morgan's laws. Let us see how we can apply the Venn diagram for De Morgan's laws. Let us take the first law, A union B dash. That means the complement of A union B is same as taking intersection of the complements of the two sets A and B. So let us understand this. Now we already know the Venn diagram for A union B. This is the Venn diagram for A union B because we have shaded both A and B. This is the Venn diagram of A union B. Now the complement of A union B would be shading leaving the two circles. So I left the two circles, I have shaded outside the two circles. That represents the complement of A union B. Okay, remember, so the complement of A union B, this is the Venn diagram of complement of A union B. Purposely I have used the two colors here, the red color and the black. The red color is the circles and the outside is the black. So the black color shaded region represents the A union B complement, that means complement of A union B. Now let us understand the right side. Now this Venn diagram represents A dash, because you see remaining is shaded in black color, and that represents A dash. Now B dash leaving B, the leaving B, we have shaded black outside, therefore it represents B dash. Now A dash and B dash, please understand, A dash, B dash, if I take what you call intersection of that, then leaving A and B I have to shade outside, and therefore A dash intersection B dash will be the Venn diagram will be shading the outside, leaving the two circles, and that represents A dash intersection B dash. So when we compare this figure, this Venn diagram with this Venn diagram, both the Venn diagrams are same, and therefore that is the Venn diagram of De Morgan's first law, that is A union B dash, that means complement of A union B is equal to the what you call intersection of the complements of A and B. Both the diagrams are same, and therefore the A union B dash is equal to A dash intersection B dash is proved by drawing the Venn diagrams. Now let us take the second law. Now this represents A intersection B. Very clearly the Venn diagram of A intersection B is this is the Venn diagram. Now A intersection B dash, that means complement of A intersection B will be the region which has to be shaded outside A intersection B. So leaving the black region here, the remaining everything is shaded. That very clearly indicates in A intersection B dash. Remember that this is the Venn diagram of A intersection B dash. Now if you want A dash, the Venn diagram of A dash will be leaving A, remaining has to be shaded that is red, and that is A dash. Leaving B, the remaining has to be shaded red, and that is B dash. And if I take the union of A dash and B dash, if I take the union, that means I have to take the red region of this, the red region of this, then we find that only the overlapping region is left with black, and that indicates very clearly A dash union B dash. When we compare this Venn diagram and this Venn diagram, we find that both the diagrams are same, and therefore we have proved the De Morgan's second law, that is A intersection B dash, that means complement of A intersection B is equal to the union of the complements of those two sets. So this is how the Venn diagrams can be used to prove the properties and the operations on sets. We'll be learning in detail by taking examples as a separate study when we study about the examples on set theory. So please go through all the properties, all the operations of sets, and very useful for calculations in about on the examples of sets. Okay, note down in a book and for your future reference. Thank you.